this is our AP Chemistry video, lesson video for Chapter 2. It's Part 3, and we're going to do Section 2.8 and 2.9. So again, just a fair reminder, you should have learned all this stuff in Honors Chem. I will tell you there is one section though that we're going to hit something new for once. When we get to Section 2.9 and talk a little bit about organic molecules, it's not very much at all this. Alright, so naming inorganic compounds. So see, we did naming in honors. Some of you had struggles with it, so you've got to get this down. Naming should not be something you have to spend a lot of time on. So cations have the same element name. So Ca is calcium, Ca positive 2 is calcium ion. Anions end in "ide." So Cl is chlorine, Cl with a -1 is the chloride ion. So when naming ionic compounds that start with a regular metal, which are our group 1 and 2 metals or aluminum, remember, not hydrogen though, then name the cation and add "ide" to the anion unless it's a polyatomic ion. So that's how we get things like sodium, fluoride, magnesium, oxide. When naming ionic compounds that start with a transition metal, then name the cation and add a Roman numeral to indicate the charge of the cation. Then add "ide" to the anion unless it is a polyatomic ion. So that's where we get names like iron, Roman numeral 3, chloride, or, copper, Roman numeral 1, phosphate, or whatever. So based on the formula for the sulfate ion, predict the formula for the selenate ion and the selenite ion. Okay, so we know elements in the same group have similar properties. So sulfur and selenium are in the same group. Well, if sulfate is SO4 -2, then selenate would be SeO4 -2. Sulfite is SO3 -2, so selenite is SeO3 -2. Okay, so the 25 polyatomic ions that are on the chart that I gave you in Honors Chem, those aren't the only polyatomic ions in the world. Those are just 25 of the most common ones. So lots of polyatomic ions, if they have elements in the same group, they'll have similar formulas in their polyatomic ion form. So it says, which of the following oxyanions, so oxyanion is just an anion, so it's negative, that contains oxygen, is incorrectly named. So we have ClO2 being called chlorate. Well, that's incorrect. ClO2 is chlorite, so this should be called chlorite. We'll check our other ones though, just to make sure more than one's not wrong. So it says IO4 negative is periiodate. Well, ClO4 negative is perchlorate, so IO4 negative is periodate. Does that make sense? SO3 -2 is sulfite. IO3 negative is iodate. Well, ClO3 negative is chlorate. So see, chlorate would go with this if it started with chlorine. And then NO2 negative is nitrate. So our answer for that would be A. Alright, and don't forget to be trying these on your own. The formula for the bromate ion is analogous to that for the chlorate ion. So in other words, bromine and chlorine are in the same group, so they have analogous polyatomic ions. So write the formula for hypobromite and bromite. Well, hypochlorite is ClO negative. So hypobromite would be BrO negative. So this would be hypobromite. And then we need bromite. So chlorite is ClO2 negative. So bromite would be BrO2 negative. So that would be my bromite. And so again, iodine, bromine, they're going to form similar polyatomic ions the way chlorine does because they're in the same group. Alright, so it says name the ionic compounds. Okay, so we know that if it's a regular metal, we just name the cation, add "ide" to the anion, unless of course it's a polyatomic ion. And if it's a transition metal, we need to add that Roman numeral. So K, of course, is potassium. It is a regular metal, so I don't need a Roman numeral. And then we normally change the ending to "ide" unless it's a polyatomic ion, which in this case it is, and it's just sulfate. For our next one, we have Ba, which is barium. It is a regular metal, so I just say barium, and then OH is hydroxide. So for regular metals, we do not need a Roman numeral. Then for our next one, we have Fe. So Fe is a transition metal, so we do need the Roman numeral. So Fe is iron. I'm going to call Cl chloride because we need that I ending. So let's just look real quick as a reminder of how to figure out the Roman numeral. So we don't know the charge of Fe. Like this is where the Roman numeral comes from, not the subscript, it's the charge. I don't know the charge of Fe because it's in the middle. We don't label those because Fe can have more than one charge. I do know the charge of Cl. It's -1. But there's 3 Cls. That's really -3. So what cancels out -3? A +3. So once I know that Fe is a +3, I know this needs to be a Roman numeral 3. So remember, Roman numerals were something that some of y'all had trouble with. You've got to get past that. We can't have trouble with that anymore. Oh, I thought I wrote chlorite by accident. I did not. All right, so it says, which of the following ionic compounds is incorrectly named? So we have zinc 2 nitrate. Well, this is zinc, this is nitrate. Nitrate is -1, and there's 2 of them, so zinc would have a +2 charge, so that's perfect. Next, we have tellurium 4 chloride. Well, Te is tellurium, Cl is negative, so if there's 4 of them, tellurium would be +4, so that's fine. Part C, diiron oxide. Well, remember, we don't use prefixes if it starts with a transition metal. We only use prefixes if it's 2 or more non-metals. Okay, so that would be the wrong one on that one. Hopefully that stood out a lot too. You've never seen me write anything like diiron. So hopefully that one was easy. All right, remember, don't forget to pause the video and try these. So it says, name the ionic compounds. So we have NH4Br. So ammonium is just a cation. So we just put ammonium, and then bromine would be called bromide. All right, next we have Cr. That is a transition metal, so I am going to need a Roman numeral. So Cr is chromium. I save room for that Roman numeral. Oxygen is going to be oxide because it's the anion. So let's just look quickly at how to get that charge for chromium. Oxygen's -2, but there's 3 of them, so that's -6. What cancels out -6? +6. But I'm going to split it between 2 atoms. So if you divide +6 by 2, they are each +3. So it would be a 3 as my Roman numeral. So remember, the Roman numeral comes from the charge, not the subscript. And so our bottom one. Hopefully you're getting these right, because hopefully you're trying them. Our bottom one, we have CO, which is cobalt. It is a transition metal, so I am going to need the Roman numerals, and NO3 is nitrate. So again, I come over here, I know NO3 has a -1 charge, but there's 2 of them. So what cancels out a -2? A +2. So once I know it's a 2, I put a Roman numeral 2 there. All right, so y'all, you've got to get to where naming is not a struggle. You need to be fast at it. Like, you shouldn't even have to stop and take a lot of time on it. Remember, the AP exam is a timed test. You have a certain amount of time to finish. All right, so next, acids. That was also a struggle for some of you. For acids that have an anion that ends in "ide," you add the prefix hydro and the suffix "ic." So Cl is chloride, so we call it hydrochloric acid. If the anion ends in "ate," we change the ending to "ic." So ClO3 is chlorate, so I call it chloric acid. So notice, even though it still starts with hydrogen, we don't put hydro in the front. And then if it ends in "ite," we change the ending to "us." So ClO2 is chlorite, so I would call that chlorous acid. And then remember, when you write the formula for acids, you need to remember to put hydrogen at the front, even if it's not in the name. So see, chlorous acid doesn't say anything about hydrogen like hydrochloric acid does. But because it ends in acid, I need to remember, oh, it's going to start with H. All right, so let's look at some acids together real quick. Okay, so HCN. CN is cyanide. So remember, if it ends in "ide," we call it hydrocyanic acid. So you can see I added the prefix hydro, the suffix "ic." All right, next one, we have NO3, which is nitrate. If it ends in "ate," we change the ending to "ic." So it's just nitrate. acid. So I changed my ending to ic. All right, for part C, we have H2SO4. Well, SO4 is sulfate. We change H to ic, so it becomes sulfuric acid. All right, and then our bottom one, H2SO3. SO3 is sulfite. We change it to us, so it's sulfurous acid. Okay, so if you're struggling throughout this naming, you need to go back to my Honors Chem videos for Chapter 9. That's when we did naming. Okay, you've got to get this under control to where you're good at it and you're quick at it. All right, I'll wait.
Jasmine Jones, you're needed in the front office. Jasmine Jones.
Don't even know why. Students are supposed to be gone now. All right, so remember, don't forget to be trying some of these on your own. So it says, which of the following acids are incorrectly named? For those that are, provide the correct name or formula. So that means there's going to be more than one, so we don't want to stop once we find a wrong one. So F is fluoride, so hydrofluoric acid is perfect. NO3 is nitrate, so nitrous acid is not right. This would be nitric acid because 8 goes to ic. You can remember I ate something icky. Perbromic acid, well, perchlorate is ClO4, so perbromic would come from perbromate, which should be BrO4, which is perfect. That one's fine. Iodic acid, well, I, when it's by itself, is iodide, so this should be called hydroiodic acid. Hydroiodic acid. And then selenic acid. So remember, we said selenium and sulfate form analogous polyatomic ions. So sulfuric would come from SO4. So selenic comes from SeO4. So that one's perfect. Okay, and don't forget to make sure you're crossing charges for these. Okay, that's how we get the 2 right here, because this would have a -2 charge and this would have +1. So we would need 2 hydrogens. Remember, every acid is not going to be monatomic. Monoprotic, which means 1 hydrogen. All right, so make sure you're trying these. So it says hydrobromic acid. Well, it ends in acid, so I know it's going to start with H, which is positive. Hydrobromic means it's attached to bromide, which is just Br negative. And so I don't need to do anything to balance my charges because they already cancel. So it's just HBr. Carbonic acid was an acid, so it's going to start with H. Carbonic comes from carbonate, which is CO3 -2. So I need to balance my charges by putting 2 hydrogens, just like that. And just remember, y'all, I can't stress enough, you don't need the charges. I'm just using the charges kind of like in math as showing my work, so you know where I'm getting my subscripts from. All right, so naming molecular compounds. So this is the one y'all liked the most, where you get to use the prefixes. So when naming molecular compounds that are composed of only nonmetals, that's how you know you're doing that. You add prefixes to indicate the number of atoms of each element. The second element still ends in "-ide". The only time a prefix is not needed is if the first element only has 1 atom. And so this is just a reminder of what the prefixes 1 through 10 are. We're not going to go back over them because you should know them. All right, so let's name some compounds with prefixes. So I have 1 sulfur. So remember, if the first element has 1, you do not need a prefix. So I'm just going to call it sulfur. Then I have 2 oxygens, so I call it di for 2. And then remember, we change the ending to I, so dioxide. All right, next one, we have 1 phosphorus. So remember, the first element only needs a prefix if it has a subscript. So I just call it phosphorus. And then I have Cl5, so that would be pentachloride. All right, so our bottom one, we finally need a prefix for both of them. So I have 2 Cl's. Now a lot of you are tempted to call this dichloride, but remember, the first element does not need I. So this would be dichlorine, and then trioxide. Okay, so don't accidentally change the ending to I if it's not the second element. All right, so hopefully all of this naming stuff is coming back to you. Hopefully it never left. but I'm sure it did. Alright, so give the names for each of the following binary compounds of carbon. So remember, don't forget to be pausing this and trying these on your own. So the first one, we have one carbon, so it's carbon, and then 2 sulfur would be disulfide. Next one, we have one carbon, so it would be carbon. 1 oxygen is monoxide. Okay, so y'all, we do have a prefix of 1 for a reason. The second element always needs a prefix. So that's why 1 is available. You just never need to use mono on the first element. Alright, next we have 3 carbons. So tricarbon and 2 oxygens. So dioxide. Here we have 1 carbon, so I just call it carbon, and 4 bromine. So tetrabromide. And then last we have 1 carbon. And then y'all be careful, a lot of you want to call this carbon fluoride, but you have to have a prefix on the second element. So it will be monofluoride, just like that. Okay, so don't forget to use mono when you need to. Okay, you just never need to use it on the first element, but you do need to use it. Otherwise we wouldn't have it. Alright, so give the chemical formulas for the following. So remember, if you have a name that has prefixes, you don't have to worry about balancing charges because it's sharing electrons, so there are no charges. So you just use your prefixes to determine the subscript. So silicon is Si, tetrabromide, bromide is Br, tetra means 4. Alright, next we have disulfur dichloride. Well, sulfur is S, di means 2, chloride is Cl, di means 2. And then last one, diphosphorus hexaoxide. Well, phosphorus is P, di means 2, hexaoxide, oxide's O, and hexa means 6, just like that. Okay, so hopefully at least the prefix ones are super easy. You might have needed a refresher with the Roman numerals and the acids. Alright, so this is where we're going to talk about just super simple, basic stuff from organic chemistry. And so this part is going to be a little new from honors chemistry. So organic chemistry is the study of compounds containing carbon. Hydrocarbons are compounds that contain only hydrogen and carbon. So like CH4 or C8H18. The subscripts can be anything, but it's just carbon and hydrogen. So alkanes are a chain of carbons that are single bonded together. So see, like this is an alkane, it's just a chain and you have your carbons single bonded together and then hydrogens fill in the other bonding location. An alcohol group is when you have changed one of the hydrogens to an OH group. Okay, so see, like here we have our set of 3 C's and they're all surrounded by H's. Well, here we have our set of 3 C's, but one of the H's has turned into an OH. All right, that's called an alcohol group. And then isomers are compounds with the same molecular formula, but different arrangements of atoms. So it says, assuming the carbon atoms in pentane are in a linear chain, write the structural formula. Well, pent means 5. So pentane means a chain of 5 carbons. So 1, 2, 3, 4, 5. And then I know that the only other element that can be there is hydrogen. So right now carbon has 2 electrons, it needs 8, so that means I need to bond 3 hydrogens. So see, 2, 4, 6, 8. Remember our Lewis-Dot structure. This carbon has 2, 4, so it needs 4 more, 6, 8. This carbon, same thing. This carbon, same thing. This carbon has 2, so it needs 6 more. Just like that. Alright, that's all you have to do to build a simple alkane. Then it says, what is the molecular formula for this alkane? Well, I can count 1, 2, 3, 4, 5. So it's C5. And then I count my hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. Just like that. Super simple. Like I said, this is really the only thing that I didn't get a chance to cover in honors chem. But super simple. Alright, it says, what is the molecular formula for hexane, the alkane with 6 carbons? So even if it didn't tell you this part, you know hex means 6. Okay, so it says, what is the molecular formula? So I know that there are going to be 6 carbons. Okay, and so my end carbons, of course, are going to need 3 more hydrogens, so 2, 4, 6, 8. My middle carbons are each going to need 2 hydrogens. Notice it's just a pattern. Like, this isn't something super difficult. It's going to take you forever to get. And then my end carbon again needs 3 hydrogens. All right, so it says, what is the molecular formula? Well, I can see there's obviously 6 carbons. So then I just count my hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Just like that. All right, then it says, what are the name and molecular formula of an alcohol derived from hexane? Okay, well, when you turn an alkane into an alcohol, instead of ending in ane, you end in all. So instead of being called hexane, it'll be called hexanol. Okay, that's what implies it's an alcohol. Sometimes you'll see a number in front of it, like it might be 1 hexanol or something like that. And then it says, what's the molecular formula? Well, all we do is we just take one H and change it into an OH. So we're still going to have the same amount of H's, we just now have an O. So you'll see it written different ways. Sometimes people will write like this, C6H13, and then they'll put the OH together, so see how there's a total of 14? Or sometimes they'll write it like this. Either one is fine. This way lets you know it's an alcohol. This way we don't necessarily know the setup of the H's notes. Like, is that O double bonded to one of the carbons or what? So you might want to write it where the OH is separate so you know for sure there's an alcohol. Alright, so it says these 2 compounds have butane in their names. Are they isomers? So see, this is called butane because there's 4 carbons. This is called cyclobutane. Cyclo means like a cycle, so you're going to have a ring. And so you can see there's 4 carbons. So remember, isomers have the same molecular formula. So let's check. So butane has 4 carbons, so it's C4. But it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So that's the molecular formula for butane. Cyclobutane still has 4 carbons, 1, 2, 3, 4. But it has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So are the molecular formulas the same? No. So these are not isomers. They are not isomers because they don't have the same molecular formula. Okay? So butane has the molecular formula as C4H10, whereas cyclobutane is C4H8. Alright, so again, I'm going to end this PowerPoint the same way I ended Chapter 1. You should already be familiar with everything from this PowerPoint except 2.9 that we just went over from Honors Chemistry. If you're struggling now, that is a problem. It is going to be an incredibly long semester. I cannot offer enough tutoring to get you through Honors Chem and AP Chem in the same semester. Okay, so y'all, you've got to get caught up on this if you're behind already. Alright, but again, don't worry, the other lesson videos for the new content will be much more informative than these are. These right now are just a review.